Okay, so let's see one thing. How do you, in the flow through pipes, how do you classify whether it's Reynolds, whether it's laminar flow or turbulent flow? So before that, let's see what is first, the laminar flow or the turbulent flow. Well, if you have laminar flow, we say that laminar flow is highly ordered motion characterized by smooth streamlines, and turbulent is your highly disordered motion characterized by velocity fluctuation. So if you want to see both, okay, let's see if somebody is smoking. So this cigar, when you light up the cigar, the smoke, if you see the smoke that goes rises upwards, for some portion it is almost orderly motion, and after that it just spreads. So this is your laminar, and after that it's all turbulent when you light up a cigar. And most of in your practical example you would have seen, light up a cigar, for some portion it's orderly motion, and after that it's disordered motion, all this velocity fluctuation. So laminar and turbulent. Well, so how do we differentiate these two? Well, we have a non-dimensional number called Reynolds number, which basically is ratio of inertial forces to viscous forces. So what it means? It means that if your inertial forces, accelerations and all that is dominating compared to your viscous flow forces. I mean, if this dominates, then you get turbulent flow. And for circular pipes, it is observed that if Reynolds number is greater than 2300, okay, you have a transition. And okay, so I'll just list out that if Reynolds number is less than 2300, it's laminar flow, viscous forces dominate, they are dominate compared to inertia forces, so there are no much velocity fluctuations. Okay, and if Reynolds number is between 2300 to 4000, we consider it is in the transition between laminar, or even after 2300 we take it to be transition, we take it to be turbulent only. But if you want to further characterize, so between 2300 to 4000 it's transition, and greater than 4000 it's turbulent. Okay, so the critical Reynolds number which we consider is 2300 for pipes, for as a demarcation between laminar and turbulent flow. Now if you have nons, so how do I find Reynolds number for circular pipes? So Reynolds number, when you apply all this inertia force, you'll get rho v, the characteristic length, by mu. Okay, and I mean the general formula that comes is rho v d by mu. This is the formula for circular flow for Reynolds number. Density, average velocity, diameter by viscosity, dynamic viscosity. For non-circular pipes, the Reynolds number is 4. I mean the formula is same, rho v d by mu, but then for non-circular pipe, this dc is nothing but 4 area of cross section by the perimeter. Let's say we have something like this, lengths are given AB. Okay, lengths are given AB. So based on that, you can find out the area of cross section A into B. The perimeter is 2A plus 2B. So that if you keep, so it's basically a converting equivalently this into a circular pipe. So for non-circular, this is the thing. So laminar, so what we are interested is how much is my head loss. That ultimately matters, because the power loss and all that will be depending on your head loss. So for laminar flow, you've already seen that for laminar flow it's Fs 64 by Re. General equation is this: FL square by 2GD for the entire head loss. So for laminar flow it is 64 by Re. For turbulent, this HF has to be, the HF has the same formula, FLV square by 2GD. This only what matters is F will change, whether it's laminar or turbulent. F is a function of your Reynolds number and your surface roughness. Okay, so there are two-dimensional numbers. Apart from Reynolds number, there is surface roughness coefficient epsilon. So this most of the time is determined experimentally. Okay, so that is how, well, so flow in pipes, your demarcation is done between laminar and turbulent. Thank you.